But anyway, Ogama is like right here. My friend used to work in the one grocery store that used to still be open in Ogama, right? Called the Locker, right? And he's working there. He's the guy that carries the groceries out to the car. And people are coming in going, looking at the roof of his car going, oh, that's not bad. You rolled this thing? That is amazing. You could just buff that out, bend the gutter, you're good, right? And my friend is like, how do you know? Oh, I read about it in the Bee. I read about that in the Apprentice Bee. Oh, that's a pretty good story. Isn't that good? I don't know. Okay, so now we have the acceleration, right? What centripetal force is needed? We have an acceleration, we have a mass. Is it possible we can just use this acceleration and use F equals ma? Yes, indeed we can, right? So F equals ma, right? So really it equals mv squared over r. You could write that down, put it on a cheat sheet, right? That's centripetal force, right? Since I've already calculated the acceleration, I'm just going to use that. So I'm going to go 1,200 kilogram car times 7.2 meters per second squared. That's going to be a lot of force needed. 7.2. Okay, times 1,200. 8640 newtons, yeah? So this is the exciting thing that, that we have you doing in the circular motion thing, is calculating centripetal accelerations, calculating forces, right? You can use these guys. You can use this. And I'll give you one more centripetal acceleration formula here. Yay. What is the minimum coefficient of friction needed? Well, let's see. Oh, that's going to be tough. I think, can't we use a formula for friction? Let's see. We've got this. Isn't friction equal to mu times m times g? Do you remember this? Yeah, there we go, right? Okay. So I'm just going to use the fact that we know the force has to be 8,640, right? So I can go 8640 equals mu times 1,200 times 9.8. So I'm going to divide by 1,200. I'm going to divide by 9.8. And I get 0.73. And it goes on and on. It's a big digit. But I'm recognizing this number as exactly the lateral acceleration. Isn't that weird? In G's. Is that always true? Yes. Yeah, it kind of is always true. And the reason that it's always true is that if we say ma, in other words, the mass times the centripetal acceleration, if that equals mu times m times g, don't the masses cancel? Yeah. And so mu is just equal to the centripetal acceleration over g, which is a weird thing. Isn't that weird? So that means that any car, assuming that it can generate the same friction, and that's where your suspension is important. The road's clean, right? It's freshly rolled asphalt. You have new tires, and the suspension is competent and keeps the car tire in contact with the road, right? Then really the lateral, your ability to laterally accelerate depends on friction. The less friction you have, like if it's on an icy road, you're less your ability to accelerate laterally, right? In my case, I went off that same road driving too fast. And I'm sorry to say it's because I hit a rabbit with my rabbit. I was going around a corner and it's just like, you know how you push it and you know the car is just about to break free from the road, right? This is not appropriate for young audiences, right? And I came around a corner and there was a rabbit, an actual rabbit, and there was no way I could avoid the rabbit because I would have just lost control of my car and I hit it and went off onto the shoulder and felt very bad. Didn't destroy my car, but did hurt the rabbit considerably. I slid on the rabbit. That's not as bad as the same guy I was telling you about. They lost one of their dogs because it ran out and attacked a gravel truck, and the gravel truck driver hit the brakes on a gravel road and on top of the dog, and the dog became sort of this greasy patch in the road. Like they heard that the dog, that's not funny, right? They heard the dog was dead, and like the younger kids went out to bury the dog. Yeah. And they couldn't find enough of it to, anyway. That's sort of sad, isn't it? Oh. All right. Whiteboard, whiteboard, whiteboard.